Passage 2 is a conflicting viewpoint. It has multiple students talking. So if we look through this passage, it's really important to understand what's happening in the passage. The teacher provided the table below to the students in a science class. The table gives 5 properties for each of the samples in A through H. The students were told to assume that each sample is a completely solid cube composed of a single hypothetical pure substance. So we have our table. We have A through H, and we have mass, volume, density, melting point, boiling point. The teacher asked each of the 4 students to explain how these data could be used to predict which samples are composed of the same substance. So student 1 says if 2 students have the same values for all 5 properties, they are composed of the same substance. So 2 samples, they have to have all 5 properties, then they are composed of the same. If 2 samples have different values for any of the 5, so if they don't equal, if one of them doesn't work, then it doesn't work. For student 2, if 2 samples have the same values for any 3 or more, so 2 samples, they would have any 3 or more would be good. But if 2 samples have the same values for fewer than 3, then they are different. So if the 2 would have less than 3, this is bad. Student 3 says if 2 samples have the same mass, volume, and density, they have the same. So if 2 samples have the mass, volume, and density, it's good. But it says if they have different values for any of the 3. So if I say 2 does not equal to mass or volume or density, it's bad. But it also says neither melting point or boiling point can distinguish between. So the degree Celsius doesn't matter. So I'm just putting no matter. Student 4 says if 2 samples have the same density, melting point, and boiling point, then they are. So 2 samples have the same density, melting point, and boiling point, then they are. But if 2 samples have different values for any of those 3, so if they don't have density or melting point or boiling point, this is bad. And then it also says neither mass nor volume by itself can distinguish between. So mass or volume, no matter. So now that we have some information, now we can answer our questions. So students 1 explanation. The same substance composes both of the samples in which of the following pairs? So student 1 says that in order for them to have the same substance, all 5 of them have to have the same. So if we look A and B, 8, 4, 2, different boiling points. So A is gone. B and C, mass is automatically gone. Sample C and D, 6, 3, 2, 237, 885. All 5 of them are the same, so it's got to be C. Question 8, based on students 3 explanation, the same substance composed both of the samples in which of the following pairs? So student 3 says they have to have mass, volume, and density to be the same. So A and C, so mass, volume, and density. So 8 and 6, nope, A and C is wrong. B and E, 8 and 8, 4 and 2, nope, automatically wrong. F and G, 8 and 4, nope, automatically wrong. G and H, 4, 4, 1, 1, 4, 4. We only have to look at those 3 because mass, volume, and density. So the answer to 8 is J. Question 9. Suppose that the temperatures of sample A is increased to 250 degrees at 1 atm of pressure. At 250 degrees, would sample A be a solid or liquid? Okay, so 250 degrees, let's look at our answer choices. Solid, solid, liquid, liquid. We have to determine that because the melting point of sample A. So let's look at the melting point of sample A. It's 126, and it went to 250. So if the melting point is 126, and it got increased to 250, then it has melted. It is no longer a solid, it is now a liquid. So it cannot be a solid, it must be a liquid, because the melting point is 126, and that's the one we want. C is our answer for question 9. Number 10. Consider the claim that 2 samples having the same density will always be composed of the same substance, regardless of the values of the other 4 properties. Which of the students, if any, would be likely to agree with this claim? So student 1 says that all 5 of them have to work, so it cannot be anything with student 1. That means if it can't be student 1, it can't be all of the students. So let's look at student 2. Student 2 says they have to have 3 of them, not just 1, but 3 of them. So it can't be student 2 would not agree with it, which means G is gone, which leaves us with J, none of the above. And as we can see, all of them say that it has to be more than just density to work. Question 11, which of the students 2, 3, and 4 would be likely to agree that sample A and sample B are composed of the same substance? So if we look at students 2, 3, and 4, we're looking at A and B have the same mass, they have the same volume, and they have the same density, but they do not have the other ones. So student 2 says any 3. It does not matter which 3, but any 3. So student 2 works because there are 3 pieces. So student 2 works because there are 3 pieces. Student 3 says they need to have mass, volume, and density. So student 3, this is student 3 automatically. So students 3 and 4 do work. So B does not have student 3 in it, so we can get rid of that. C does not have student 2 in it, so we can get rid of that. So now we got to look at student 4. Student 4 says they need density, melting point, and boiling point to work, which is not in here, so it's not student 4. So D is gone. The answer is A for 11. Number 12, consider the statement, 2 samples that have the same mass, volume, and density and boiling point are composed of the same substance, even if the 2 samples have different melting points. Which students, 2 and 4, if either, would be likely to agree with this? So we're looking at mass, volume, density, and boiling point. So looking at student 2, it needs to have 3 or more that are the same. So student 2 is good. Student 2 would agree with this. Student 4 says that they have to have density, melting point, and boiling point. Well, this does not have the melting point, so student 4 would not agree with this. So student 2 does. So the answer would be F. Last of this passage says, suppose that the temperature of sample D, so go to sample D, is increased to 890 degrees Celsius at 1 atm of pressure. Will the sample's density be lower or higher than at 20 degrees Celsius, which is what it's at? So if we increase sample D to 890, so we're going to go to 890, so that is past its boiling point. So this is now boiling. So we don't know lower or higher right now, but we can say sample D will be a gas or sample D will be a liquid. So if it's boiling, it is now going into a gas state. It is no longer a liquid because it is, melting point is where it goes from solid to liquid. Boiling point is when it goes from liquid to a gas. So it is no longer a solid. So B is automatically gone because it's no longer a liquid. B is gone. C says will be a gas. D says will be a liquid. So D is gone because it says liquid. So will the density be lower or higher? Gases generally have lower densities than solids. That is a true statement. Gases generally have higher densities than solids. That is not a true statement. So that piece is where it's wrong. A is the correct answer.